So here's the problem. I do love to listen to music while showering, but my music system currently looks like this. No hate against this Bluetooth speaker though, because it has been surviving in a rather wet environment for around 8 years now, which is impressive. But the audio quality is obviously not the best, and I hate charging this thing up every week. Now, I did come up with a DIY ceiling mounted Bluetooth music system in a previous project video from 10 years ago. And I thought, yes, I can do the same thing in my new shower. But then I had a closer look at the utilized products and realized that some were pretty outdated. And most importantly, while checking my created circuit from back then, I also noticed that it does not work the way I hoped it would. So in this video, let me show you how to create a modern, awesome sounding ceiling music system that I honestly feel like is my favorite home upgrade so far. Let's get started! Designing advanced electronic circuits just got easier with my sponsor JLCPCB and their 6-layer PCBs. By using those, you have significantly more routing space, meaning you can manage more complex designs and even high-density components as well as intricate trace patterns, without having to increase your board size. And right now, for a limited time only, you can get a $30 coupon for their 6-layer PCBs. So why not try it out by clicking the link below to claim your coupon. Now, building such a project basically consists of 4 parts, with the first one being the speaker. Back then, I simply used one I had laying around. But this time, the speaker will get mounted pretty close to my shower, meaning it should withstand moisture and water. That means I had to pay attention to the IP rating, which comes with 2 numbers, with the second one classifying the liquid ingress protection. And I think number 4, meaning splashing of water has no harmful effect, should be sufficient. So I looked through all corners of the internet to ultimately find this IPX6 speaker set, which, according to the rating, even withstands powerful water jets. All the other specs also sounded suitable, including the depth of the speaker, which my ceiling does luckily offer, and thus I ordered them, and to my own delight was very happy with their quality after receiving them. And by the way, they also sounded awesome later on, and definitely packed a good punch. But anyway, with the speaker selection complete, we move on to the power supply. And here comes my old circuit into play that, let's be honest, I designed incorrectly. To better show you the problem though, let me quickly build up the circuit on a breadboard. Now, when injecting a small sine wave on the input of the op-amp that looks like this, then we get a bigger sine wave on the output that oscillates around an offset of 6 volts. So far this is correct, because I set this 6 volt offset here, and we need that because my voltage supply only goes from plus 12 volts to ground. And we want to use most of this voltage range for our music, which we can do with a 6 volt offset. But after this op-amp, I tried to build up a Class B transistor output stage, which, long story short, does not function with the given voltages. To prove it, let's simply hook up a small load as a speaker replacement. And yes, we can see that audio amplification took place. But when using the thermal camera, we can easily see that only one transistor is doing all the work, meaning we can remove the lower one and it would not change anything. So to solve this problem, we firstly need a power supply that provides plus and minus 12 volts for the new design. And let me tell you that those are not that easy to find. So instead, I did a small trick by using 2 identical 12 volt power supplies. The idea here is that I put the output of the power supplies in series to basically create 24 volts, that I can then split into plus 12 volts and minus 12 volts. And as you can see, that works perfectly fine, and later on they did their job just fine. And that brings us to the third step, which is the Bluetooth music receiver. Now back then I used the Bluetooth 2.01, which created a horrible interference sound when powering the audio amp and Bluetooth receiver with the same power supply. But you know, technology evolved, and nowadays you pretty much only get Bluetooth 4 point something or Bluetooth 5 point something, which hopefully no longer comes with interferences. So for testing, I got myself a whole bunch of different boards to find out which performs best. And I gotta say that after testing most of them, I was rather happy. Now they still do feature a slight interference sound, but you can barely hear that, and during music playback it is not noticeable. And best of, there is one board that features no interferences whatsoever, and that is because it is utilizing such an isolated DC to DC converter. Now granted, this board is a bit more expensive, but then again it comes as a 12 volt version, meaning I can directly power it with my 12 volt power supply later on. And when powering it up, there is no Chinese person speaking English, like you can hear with most other boards.
Bluetooth mode.
So yeah, this is the one I'm going with. And truth be told, if you combine this board with such a PAM 8406 audio amp board that you can also get for pretty cheap, then you already got a decent sounding music system that is definitely good enough for a shower. But for me, it is not about sounding good, but about sounding awesome, with as little distortions as possible. Which directly brings us to the last part, the audio amplifier. Now before presenting my new design, I measured the total harmonic distortions, or THD, after my Bluetooth receiver, by simply playing back a sine wave with a frequency between 20 Hz and 20 kHz, and then analyzing that with my oscilloscope's spectrum analyzer. And after then hooking up the PAM amp and doing the same measurements again, it seems like the THD increased a bit, but not in a way that audio would sound horrible. I mean, it is actually impressive, considering how easy to use this IC is, and that it apparently acts as a Class D amp. But anyway, I want even better results by altering my original schematic slightly. Now the original NE5534 op amp with its low noise is not bad for audio applications. But when having a look at this chart created by ChatGPT, then you can see that the LM4562 is king here, with even less noise and a ridiculously low THD value. Only problem is that they're quite expensive, but I got myself one for this special home upgrade. And for the transistor output stage, I went with these two, mainly because their datasheets claim that they're suitable for high fidelity audio amplifier. And with the main components in mind, I started tinkering around with the op amp and transistors, in order to ultimately end up with an awesome sounding design, whose schematic looks like this. Now I showed off at the beginning what the op amp does, but now we finally got a functional Class AB audio stage here, whose predecessor, the Class A amp, I actually showed off in a previous video. Such a simple Class A amp sounds amazing, but it wastes a lot of power, because the transistor is basically always turned on. A Class B amp solves this problem by using an NPN and a PNP transistor like this. The positive audio signal only controls the upper transistor, while the negative audio signal controls the lower transistor. This way both are turned off when no audio is playing, which is a lot more efficient. Only problem is that such BJTs only start conducting at a minimum voltage of 0.6 volt at their base, meaning some audio signals simply get ignored, and thus you once again create distortions. To solve this problem, we use a class AB amplifier, which simply adds an offset to the bass so that all audio signals get noticed. I use the potentiometer here to fine adjust the bias resistance values in order to find the sweet spot at which the distortions were the lowest. In my case around 2 kilo-ohm, which equaled a quiescent current of 80 milliamps that goes up to a maximum of 300 milliamps while blasting music. At which point my amp not only was louder than the one before, but also featured overall less distortions. So I soldered the circuit to a perf board before doing one final test, to make sure that the transistors do not overheat. And at this point, I decided to add a small heatsink just to be on the safe side. Last but not least, I made the electrical wiring a bit more safer by adding an enclosure, a fuse on the DC side, a fuse on the AC side, and even a Shelly Mini to the AC side so that I can turn on and off my music system whenever I feel like. And that meant it was time to determine a suitable spot in my shower and create a 12 cm hole there so that the speaker fits perfectly. Then I grabbed myself some mains power from the LED spot that was already mounted there. And let me warn you here that working with such mains voltage should only be done by professionals. With that being done, I stuffed all components into the ceiling and closed it all up with the speaker and its included screws. And just like that, my best home upgrade so far was done and is working perfectly. I hope you liked it, and if so, then consider supporting this show on Patreon to keep it going. Don't forget to like, share, subscribe, and hit the notification bell. Stay creative, and I will see you next time.